But first, let me introduce you to Prospective API. And so Prospective API, now been developed and managed by Google, offers us an opportunity to automatically analyze any social media posts according to different toxicity dimensions. So this chart from the website can nicely represent the way it works. So you have a message like the one shown here, "Shut up, you an idiot!" exclamation mark. And so you send this to the system, to Prospective API, to Google Cloud, and then it analyzes it using machine learning approach, and it sends you back scores according to different metrics. The more common metrics, it's just toxicity, and the score is actually ranges from 0 to 1, and indicates, more generally speaking, likelihood, how likely that particular message that we just analyzed is, in this case, toxic. Then there's a measure called severe toxicity, and we will go through definitions for each of these measures, because we do need to understand what they're trying to, what manifestation of antisocial behavior they're trying to capture. Then under the severe toxicity, this particular measure was only scored 0.75, so maybe less severe. Was it insult? Well, the system thinks it is. It assigned 1 out of 1, from 0 to 1. Was it sexually explicit? No. And the score reflects that. It's very low, close to 0. Profanity, does it include profanity? Yeah, it includes words like idiot. So the system correctly picked that up. Likely to reject? Well, the Prospective API, I should mention, was originally developed as a way to help moderators of different forums and newspapers to moderate their comments sections. And so this likely to reject, it's a kind of aggregate feature. We're actually not supporting it in Communalytic because it's very platform specific. But the idea is that essentially is how likely a moderator looking at the message will reject it because it's against their policy. Then you have metrics like threat. So those are usually trying to capture directed attack, like somebody is trying to kill someone. I do find a lot of false positive results for this category. So I usually personally don't rely on that. We'll talk about that later. But in this case, the system doesn't think it's a threat to an individual. And finally, there's a category called identity attack. And so identity attack is when somebody posting insulting messages or toxic messages directed at specific group in our society. Like a minority group. And so in this case, the system didn't see that it's identity attack, and that's why it scored very low. So that's how it works. And so the idea is we want to integrate, we want to be able to apply this analysis to any data set that you've collected via Communalytic, which can come from Reddit. Today, I'll show you examples from Reddit, but later in this in the bootcamp, we will also look at how do we interpret the scores for Twitter data sets, for example. And in fact, we'll have a guest speaker in 2 weeks. We will announce a little bit later, who did use Communalytic and Prospective API to analyze sentiments around wearing masks to prevent the spread of COVID-19. So a very interesting case study based on Twitter, but that's coming in 2 weeks. Just a preview. All right. So how Google came up with this algorithm? Well, when we're talking about machine learning approach, we always have to think about what was the training data set, what was the data set that was used to train this machine learning approach. In their case, they started it with more publicly available comments data set from Wikipedia. So Wikipedia has what most of us know as Wikipedia pages, more information about different people or entities. But behind each page, there's a sections where editors, wiki editors, trying to kind of debate and discuss what to include, what to exclude. And so there are lots of, or sometimes conversation can be very hostile. And so there are publicly available data sets that people from Prospective API used to train their machines. The New York Times comment section was also used for training purposes. And the idea was very similar to what Philip presented actually in case number 1, where this group asked many human coders more than 3 per message. I believe in some cases they had 5 or even more quarters to identify whether a comment was toxic or not, whether a particular comment was insulting or not. But by having many quarters, you can get an average agreement overall around each post. And that's how the machine learning was trained. And there are multiple techniques. It's really outside of the scope of this bootcamp to talk about different machine learning approaches. But here, as reported, they use the latest or known, the approach that's known to perform very well, convolution neural networks, CNN, not to be confused with the news station. Anyway, so this is if you're relying on Prospective API to publish your papers, this is kind of methodology related information that you can include. Now let's quickly go through each of the 6 primary measures provided by Prospective to see how it's defined, to look at each example. And so let's start with more broad one, toxicity, and broadly defined as message rude, disrespectful, or or generally unreasonable. And it doesn't have to attack an individual or a group. Example, this is one of the stupidest things I've read, but F me, I laughed at the second line. So it's toxic. It's maybe not in a harassment type of post, but it does use a lot of swear words. But then there's a category called severe toxicity. So it's a version of toxicity, but kind of on with a bit higher threshold. So it consider very hateful, aggressive, disrespectful posts. And the scores are less sensitive to posts that included positive uses of curse words. So F off, pathetic loser. No one cares about your worthless opinion. So this is, you can see the message is really much more kind of toxic, essentially. Insults, so insulting, inflammatory, or negative posts towards an individual or a group. So insult, there are few of them, and we saw that in our case study when our human quarters look at the posts towards politicians, where we saw the number of insulting messages much fewer, which you want to see if you're looking for healthy online conversations. But it's also important to capture those. Example of insulting post could be how F stupid is and the name of the person. So it's not, this one is not directly insulting an individual, but because they mention it, it is kind of directed towards a particular person. And I will continue reading this. That is pretty F stupid. What's next? A deep fake? Having him say racist things as a social experiment? Question mark. So you can see it has different kind of properties than general toxic or severe toxicity type of posts. And the main differentiator is that it has a personal name, organizational name, or identity group mentioned in the post. Now, there is also subcategory of posts that are called identity attacks. And so those are negative posts attacking someone because of their identity. It could be race, gender, sexual orientation, ideology, religion, nationality, and other identities. Example could be here. You people are a bunch of Fs, and I voted for and the name of the party. So I see also Anton asking, is inflammatory language is a requirement for toxicity? It depends. In our work, we do see there's an overlap between toxicity score and insults. And I'll show you correlation results. We correlated, measured correlation between all these measures. So you'll see there's a high correlation, but insults are much more a smaller category. In many cases, I would say it's a subcategory of toxicity, but there are some nuances when it's not as toxic or determined not as toxic by the system. But most of the time, if someone insulting, it's also toxic. Yeah. Yeah. Profanity. And so the profanity, this is most closely related to the dictionary approach that I showed you in the case study 2 about the Indian women of influence, where we had our predefined swear word dictionaries. This is very similar. It will capture any posts that include swear words or some kind of obscene language. An example could be, why vote for the name of the party when you know they won't win an S word. All right, and finally the threats. So post with an intention to inflict pain, injury, or violence against an individual or group. I haven't seen many of these, and hopefully you won't see many of those in the datasets. If you do, it's very problematic for groups and of course individuals who might be on the receiving end. So example could be shoot all yellow vests. We have to kill all Nazis. And so what I noticed, Prospective API picks up, ranks messages that includes words like shoot or kill high on this scale. And I do find sometimes more false positive results for this category, simply because it's they're very small examples this dimension was trained on, I'm assuming. And because the use of words like shoot me, I love it, can be used in a positive way too in slang, sometimes it creates those miscategorizations. So this actually brings us to how do we evaluate, or how did Prospective API evaluated their models? Can we rely on machine learning? Some of you might have heard criticism of this machine learning approach to identify toxic messages. So let's dive deeper and see how it was evaluated and what kind of things we have to keep in mind. And so what I want to say that the Prospective API right now published their formal evaluation based on their most generic metric, the toxicity score. And so for your publications, I think if you're doing it at scale, without any interventions or any sampling and manual cross-validation of your results, I think it's safe to rely on toxicity score, that the most general definition of toxicity. And you can always cite the provided evaluation metrics. For other scores, they're not formally published, at least not on their website yet. You still can rely on Prospective API to identify or label flag messages that might be insulting or include identity attacks. But I do suggest to kind of manually cross-validate the results, at least based on a sample of your results. All right, so let's look at toxicity score and how it was evaluated. And so to evaluate results of a particular algorithm, machine learning algorithm, in this case, we call it classification model because it classifies messages as toxic or not. We want to look at the true positive rate and false positive rate. So let's just briefly define true positive rate. Some of you who are familiar with machine learning will also know this metric by recall. It's called recall. But true positive essentially calculates the percentage of messages, toxic messages, that were able to be identified by the system. So if there are 100 toxic messages in the data set, and your algorithm only identified 80 out of 100, then the true positive rate will be 0.8, so 80%. So we would be somewhere here. So that's the true positive. So it's clearly you want to increase true positive rate. You want to get all 100% of toxic messages identified. On the other hand, if we look at the false positive rate, it's also an important metric. It essentially looks at the percentage of messages that are not toxic, but they were labeled as such. So they were misclassified. They falsely were said these are toxic messages. Well, they're not. And so the task of machine learning or evaluating machine learning approach is to maximize, to see how well the algorithm maximizes the rate of true positives while minimizing false positive results. Well, the challenge is represented here using this, what we call ROC curve, or receiver operating characteristics curve. And so you can see here for the toxicity score for Prospective API, as you increase the true positive rate, you also at some point starting to noticeably increase the false positive results. So for example, if we were looking for everything that includes F word, as we included more messages with F word, we might be also including messages where F word was used in socializing in a non-toxic way, for example. And so it shows you that it's really hard to get 100% true positive rate without including at least some percentage of false positive results. And so essentially you have to kind of choose your threshold. And to decide, sometimes it depends on your research questions. Sometimes it depends on the data set. So if position 1, for example, will allow you to identify true positive rate about 40%, you can identify 40%, and in that 40% of your results, there will be very few, like close to 0 false positive results. So you will know that the 40% you identify, maybe it's not all toxic messages, but the ones you identify, there will be fewer false positive results. And maybe that's all you need. And that, for example, settings may be good for identifying spam in your emails. So spam in your emails, you don't want to label your emails from your colleagues as spam. So you don't want to increase false positive results too much. But you do want to capture the ones you label as spam by your email client. You want to make sure that it is actually spammy. On the other hand, I think for when we're looking at toxicity analysis, in our case, we're looking at position somewhere near 2, where we at the verge of this curve line turning and increasing the toxicity score. Increasing false positive results, but while maximizing our true positive return. Because at some point, even if we get all near 100% of true positive, then the false positive will be too high, 40%. And then the results also not accurate. So it's a balancing act. And what a machine learning field suggests that instead of looking at this curve line and looking at different positions, like the way we look at it, we can summarize the performance of a machine learning algorithm by looking at, by measuring this space under the curve. It's called area under the curve. And so if you actually calculate this area and you come up with this number, you don't need to do it manually. Most of the programs can do it automatically. So you can get a number between 0 and 1, and it's called AUC, area under the curve. And so this value suggests that the model will perform poorly if the score is close to 0. But it will predict 100% correctly if the score is 1. But we know that it's nearly impossible to get AUC score of 1. Based on the literature, how do you evaluate, what's the good value of AUC? And we will see this metric in a couple instances later. And so we need to know what's considered to be a good AUC. So the score is 0.9, outstanding. So for toxicity score, as shown here, prospective API gets the AUC score of 0.096. So it's in the outstanding range. 0.8 to 0.9 is excellent, and 0.7 to 0.8 is acceptable. So, which means that anything that you see below 0.7, you cannot really trust the machine learning approach that produce AUC less than 0.7. So I would not even use it for publication. Any quick question about these two concepts, the AUC or ROC curve in general? Just want to make sure this part is clear, because we're going to use these numbers to evaluate unintended biases in prospective API. So I hear no questions. So why don't we continue on? And I'm also keeping an eye on time. It's almost 11 o'clock here in Toronto. And we said the session will be 1 hour and 30 minutes. So let me take the next maybe 10, 15 minutes to show you the rest of the evaluation. And then we will stop recording and we'll open up for your additional questions. So when we evaluate the machine learning model, we can certainly look at this more generic AUC approach for the whole data set, for the whole results. But when we're talking about toxicity, we also need to account for unintended biases in machine learning models. Essentially, these are examples when some words in some cultures may be used either in positive or negative context. And so if the word is used in a negative context, and machine learning is trained on those negative examples of that word, then it may start associating that word with only or mostly negative examples. So the word gay is a good example because in slang with some cultures, somebody may say, "Oh, it's so gay," meaning that it's bad. So if somebody train the machine learning on examples like that, and the machine learning will say, "Oh, every time there's a message includes the word gay," well, it's probably negative. It's toxic message. But look at this example. The Gay and Lesbian Film Festival starts today. It's just an announcement. But if you naively train the machine learning algorithm without considering those unintended biases, the toxicity score may be quite high for this message when it's not. There are other examples for other words, like being transgender is independent of sexual orientation. Well, there's nothing negative about this statement, but it's just informative statement. But the toxicity score is, halfway through, so it's higher than it should be. And same with the third example. A Muslim is someone who follows a practice or practices Islam. And again, it's not clear why the toxicity score is as high as 0.4 here, because this is just a general statement, but it's because a machine learning algorithm might have been trained on examples where words like Muslim or Islam might have been used in a negative context, or as if somebody were attacking people because of their identity or religion. And so Prospective API, the first version, was somewhat criticized for not accounting for these unintended biases. And so since then, now they released version 6, and that's what we're using right now. They improve their both evaluation and the performance of their toxicity analysis on this to account for unintended biases. To do that, what they did, they subdivided their training evaluation data sets into 3 groups. One is they call it subgroup AUC, where they included only examples that mention the specific identity subgroups. And so we already talked about AUC values. So AUC value generally summarizes how well a machine learning model works. And so a low value in this metrics for this group will indicate that model does a poor job of distinguishing between toxic and non-toxic comments that mention the identity group. The second group sample they divided it is they included non-toxic examples that mention the identity and toxic examples that don't mention the identity. So they're trying to play this trick with the machine learning approach to see how well it can differentiate the two. And so for this group, a low value of this matrix will likely suggest that the model predicts higher toxicity scores than it should for non-toxic examples mentioning the identity, like that Gay and Lesbian Film Festival. So if the model assigns a toxicity score for that statement high, very high, then it means it did poorly for this second test. The third group included toxic examples that mention the identity, but non-toxic examples that don't mention the identity. And so if the AUC values are low for this group, then it means that the model, the classification model, likely predicts lower toxicity scores than it should for toxic examples mentioning the identity. So it's kind of reverse of the second test. And so you'll see that this a bit more clearly in this next example. So this is the what a Prospective API calls a report card. So report cards. So they identify certain keywords here that belongs to different identity groups based on religion, race, ethnicity, sexual orientations, and so on. And so this is just a screenshot, and the link is on the slide, and we will share all the slides by next week on the bootcamp website, so you can have all the clickable links to explore further. But essentially, the words like lesbian, gay, queer, straight, and so on relates to different identities. And these are single words and relates, assuming that it relates to person belongs to one single identity. That's why this test called unitary identity. Later on, we will do a cross-sectional identity test. So the numbers you see here, these AUC numbers, the ones that we've talked about. And so each column is a different test, different subgroups. And what you can see on the left side, the scorecard for version 1 that Prospective released in 2017, and then version 6 released a year and a half later. And so the densely colored cells highlight some of the low performance scores. So remember, we talked about the AUC values thresholds. Anything below 0.7 is not acceptable for machine learning. And you can see here clearly that in version 1, any posts that included word like homosexual the model will perform fully. The AUC for certain tests will be 0.5, which is not acceptable. And this indicates that model would likely predict higher toxic scores than it should for non-toxic examples of that group. And so by probably training the model to look for those keywords, the latest model produced AUC for the same test 0.96, which is in the outstanding category. So that's how you read the scorecards. And it's quite hard, as I mentioned, to reach 1, the value of 1 on AUC. So anything above 0.9 should be considered as great, as acceptable. Now, because people can belong to multiple identity groups, they also produce report cards for intersectional identities, where there are 2 keywords that indicate 2 different identities. So for example, we'll look at the first example, black, gay. So the person is black and also gay. So it's that's why it's test intersectionality. And so you can see a lot of darker colors in the version 1 under the second category, second test. And again, this is test where examples, these keywords like black, gay would be assigned, any messages with these keywords will be treated more toxic or will be assigned as having higher toxicity score when they should not be by the system in the version 1. And in the latest version, it's not 0.9 and above for the black gay keywords. It's but it's pretty close. It's 0.89. So it tells you it's not foolproof, but it's in the what literature suggests excellent category for AUC values. So it's much improved. But this gives you an idea why machine learning, the use of machine learning to identify toxicity, and in general, in Prospective API in particular, has been criticized for misclassifying certain things. But you can see the improvements here. And certainly for your publications, I always recommend to get a sample of your messages to cross-validate some of these results as well. So now, to show you quickly, and we have a tutorial, if Tiago, you can post a link, we do have a tutorial how to use toxicity analysis in Communalytic on the website, as well as how to access Prospective API on the website. So that's why I'm gonna go very quickly for this part. And this is the last part for today. You can access Prospective API either using some kind of programming language like Python script, or in our case, you can use a web interface. That's the whole point for developing Communalytic, so that non-programmers can actually use easily interact with APIs like Prospective API through the web interface. And so that's what I will focus on. I will use example from Reddit, and I will use dataset we've been studying from a group called Meta Canada, a forum largely, but not exclusively, populated by conservatives. And in fact, since last year, it moved away from Reddit because some of the members of this group felt they were overly moderated. So we collected data around the Canadian federal election in 2019. So it's similar time frame that case study 1 that Philip presented on. but the data is coming from Reddit. And there were about 20,000 messages posted to this group over this period of time, right before and after federal election here in Canada. And once we collected the data, and that's we discussed last time we met, we now want to analyze all the messages we've collected to assign those toxicity scores using Prospective API. Well, first we need to add the Prospective API key, because each of you will get your own Prospective API key. And once you have it, you will go to under my profile section of the website and enter it to your account. So nobody else using the system will have access to your key. And the reason it's important to get your own keys because Google limits how many calls, how many messages you can analyze every minute. And the rate is a bit low. They only allow us to analyze 10 messages per minute for each key. So as a result, so it's not Communalytic specific. This is really Google API specific. So as a result, it really makes sense to run this analysis on the background. So Communalytic would be useful in that way. You can start the analysis and then come back to it in a day, depending on the size of your data set. But before you can enter your key, you need to get this key. So so if you go to Prospective API website, they outline the steps you need to request it. You need to have your Google account, and because you sign into Communalytic, I'm assuming you have your Gmail ready to sign in. Keep in mind, if your institution has Gmail-based account, it doesn't work very well with Google Cloud. For example, here at Ryerson University, our emails are also based on Gmails, and I generally can sign into Gmails or other services. I can use my account to sign into Communalytic, but I cannot use my Ryerson Gmail with Google Cloud Console. So keep that in mind if you get an error when creating a project in Google Cloud Console. You might have to create a separate Gmail outside of your institution. So once you're in this Google Cloud Console, it will look something like this. And to use any APIs that Google provides, you have to create a project, what they call it. And this is also outlined in the steps that Tiago shared with you in the chat room. So you create this project just so that Google can give you permission to this project to request to run the Prospective API. When you're creating a project using this interface, you want to write down the project ID. I highlighted it here. So the project name you assign, but the project ID is automatically assigned by Google. And this is something you need when you applying to get access to Prospective API. So just make sure you copy and paste the project ID because you'll need it for this form. So this is a simple Google form where you just specify your name, affiliation, and that project ID. Google team promise to respond to you within a day or two max, and they're generally fast to approving your requests. And so once they approve it, you get the message that it's approved. You can go back to your Cloud Console link. And so now you can actually go to within this Cloud Console, within your project. You can see, for example, in my case, I'm under my project 33805. It's whatever name you entered it. But what I want to do, I want to go to API libraries section or library on the left side menu so that I can locate the specific Prospective API and enable it. Because by default, even though you approve to get access to the API, it will disabled by default. So once you can search for word Prospective within this API library because there are many APIs. So you can browse it, or I found it easier just to search for Prospective. And so you'll see this Prospective Comment Analyzer API. So you clicked on it, Prospective Comment Analyzer API, and then you have to say enable it. So that's an important step. And I also noticed once you enable it, it may take 1 hour or two for your permissions to kick in, because sometimes if you try to use a Prospective API right away in Communalytic, it may give you an error. It will say, oh, toxicity analysis is stuck. It's stuck. But it's because there's a delay when after they approve it, maybe the system needs some time to recognize your credentials. But you're not done yet. So we're still within this Google Cloud Console where we found the API, Prospective API, we enable it. But now we need to generate credentials for Communalytic or other scripts if you want to use outside Communalytic to access this API on your behalf. So this is where you go to credentials menu in your Google Cloud credentials. And under the credentials, you just hit create new credentials. So there's a plus sign here, create credentials, and you will select API keys, API key. That's a single key. It's a combination of different characters, and it's simple as that. So it generates this long series of numbers, characters. You copy the key, and then this is what you want to enter under the profile. Enter the key. So now every time you request to run to toxicity analysis, it will use your key to make sure that you have access. So there are multiple steps to get the key and then enter the key. And I know at first it may be a bit overwhelming, but the good thing that you only need to do it once. Once you get it approved, once you get the key, you can use it for all of your data sets. You don't have to re-enter it, anything. And also we're here. So if you have any challenges with the steps, we want to support your work. So just email us info@socialmedialab.ca, and one of us will certainly help you with that. Once we have the key entered, and now we want to analyze this Meta Canada, in my case, data set, you go to my data set page, you will see something like this. There is a lightning sign for toxicity analysis. We had an interesting discussion with Philip, like what would be the symbol to represent toxicity analysis so that it's kind of intuitive for this interface to have. So Philip suggested lightning sign. So you can blame or thank him for that. But this is it. So you click on that lightning sign. Alternatively, if you want to access, if you already view in your data set with this zoom box, if you're in this overview page, on the left side, you also have a button called toxicity analysis. That's another way to access the toxicity analysis page. Once you're on that page, there are a couple of points I want to make. There are lots of documentations. And again, the tool is designed for researchers, by researchers. So we often include a lot of information so you can have it for your publications. Because I think for this type of work, you have to be very transparent how the data was collected, how it was analyzed. It's somewhat different from more, commercially marketing-oriented products for social media analytics where you don't have any of this. So that was, I just want to say, that's a design choice to include the text. And so what this text tells you is that, well, you can run toxicity analysis in multiple languages. I believe it's now 7 languages. And I think, Tiago, if you can post those languages into the chat room would be great. So English, Italian, French. They recently, Prospective API recently added support for Arabic. We about a couple of weeks behind when Prospective API adds a new language to support. Because they have to train the algorithms on new language. So we're planning to add Arabic language for Arabic in June, but otherwise there are 7 languages already implemented. So you kind of have to determine. So Communalytic will try to automatically identify based on first 100 messages or so in your data set, what language it's in, what's the majority language. And if it's English, that's what the drop-down menu will show. But you can always override it. So if you know that your data set coming from, let's say, Russian-speaking subreddit or Italian-speaking subreddit, you need to change that. Otherwise, your scores will not be accurate. The other point to make is, so Prospective API has a limit as to how many characters they can analyze per call. So right now, posts longer than 300 characters will be automatically truncated. So most of the, social media conversations will fit under that category. Tweets 280 characters. Reddit posts are rarely that long. That would be an essay. And frankly, the longer message it is, I find it as toxicity scores perhaps would be less accurate because there are many themes emerged in that conversations. But keep that in mind. So it's any messages that longer than that, it will be truncated, and only first 300 characters, 300,000 characters will be analyzed through Prospective API. We also remove URLs just to make sure in text, just to make sure they don't bias the results. If you analyze and tweet, and we'll talk about it, we don't remove hashtags right now, but keep in mind, because some hashtags will have negative words or keywords part of them, and that can also change the toxicity scores. And so once you finish, once you start analysis, you'll see this progress bar. And this is what I'm talking about when I said prospective API only allows us to run 10 messages per minute. So it's somewhat long process, and we estimate how long it will take. You don't have to stare at the progress bar. Sometimes I do enjoy it, and I click check progress button to see the progress. But if it's a large data set, it's best to just wait and come back next day to see where you're at.
Hi, Anatoly.
Yes, Philip,
just
jump
want to
in.
quickly
Yes.
mention the prospective API. That's the standard they give to everybody when you first apply. But there is also a process for you to get an upgrade. So if you find that the process is taking too slow because your data set is too big, you can always go back to prospective API and request an upgrade. And usually they will grant that. So this way your rate limit is going to be a lot higher.
Yeah,
but like
well,
I said, for most people, it will be enough.
Yeah, thank you for mentioning, Philip. And so right now in Communalytic, though, there's no way to flag what rate you use if you have an increase allocation. So if you do have that allowance increased to, usually they increase it to 100 messages per minute. So for example, for our research account, we did requested that a special increase, and it was a straightforward process. Just describing what research project you're doing, and it was 100 messages per minute. So if you do want to use, if you did receive that increase and you want to use it in Communalytic, please email us at info@socialmedialab so that we can manually enable it for your specific account. Because right now the system by default will assume that you have default 10 messages per minute rate. Once you finish, regardless of your rate limit, you will see this table in Communalytics that summarizes common metrics. And keep in mind, for some non-English datasets that prospective supports, some of these categories will not be available. And just has to do with the available training datasets. For example, sexually explicit and 13, I think threats is there, but 13 will not be part of non-English datasets. Just keep in mind that this list may change, but you always will see the toxicity, severe toxicity, and identity attack and insults for any languages supported by prospective. We show an average, but average toxicity score for the whole data set, sometimes misleading. We also show highest value and low values. Usually you'll have some highest values close to 1 and lowest values close to 0. What you can do here is to click on each of this score, and it will bring you to the new page, which shows you like top most toxic messages based on a particular measure, just to validate, to make sure that toxicity analysis identify or use the language properly. And in this case, I see a lot of F messages, so it looks like it picked up the toxic interactions pretty well for this data set. The other thing is to look at is the distribution of scores from 0 to 1. Remember, each score listed here is a range from 0 to 1. So close to 1 is more likely to be toxic or insulting, depending on the measure. So we provide these distributions for each score for your data set to give you an idea, what is the relative ratio of non-toxic, which is something below 0.5 for sure, versus close to 1 scores. Most of the distribution charts will look left-leaning, so they will be skewed towards left because most of the messages you'll find are not non-toxic, which is expected. But if you look at, so this is an example of this distribution charts I'm talking about. And essentially, you can see most of the messages here are non-toxic, but then there's a spike here close to 1. So this is the group you are interested in exploring. There's a small percentage of messages that were scored close to 1. So those are toxic interactions. But then if you apply a stricter threshold, a severe toxicity, this bump at the end is not as pronounced. But then if you're just looking at profanity, like swear words, the bump is the spike in numbers messages with swear words is actually higher than just regular toxicity. So you can see each metrics perform slightly differently, and the idea is to explore those spikes close to the one area. But where's the threshold, you ask me? Like, what is considered to be toxic? So if we're talking about toxicity score, is 0.5 a toxic message? Is 0.6 toxic message? Well, Prospective API purposely doesn't give you a threshold because threshold will change number of false positive results. The low threshold is more likely if you will find all or most toxic messages, but it's also more likely that you will include false positive results. So you really have to consider your research questions, your data sets, to determine the thresholds. In our experiments, so just to give you an idea for this Meta Canada Reddit group, which was somewhat toxic, I would say. So in this table, we present results, percentage of toxic, severe toxic messages, and so on, based on threshold of 0.7, 0.8, and 0.9. So if we count number of messages that received a toxicity score 0.7 or above, there were 15% of them in the data set of 20,000 as toxic. This is a relatively high number because remember, for other groups we presented in case studies, we only had around 3, maybe 8% maximum. 15% is quite high. But look what happened if we move the threshold. If we say what we consider to be toxic is a message that received a 0.8 score or above, then the percentage of these messages is smaller, 10%. And even so, if we go with 0.9 threshold, only 5% will be considered as toxic. And you can see similar effect happens for other metrics, like severe toxicity with threshold 0.7 and above. It's 6% of messages classified as such, and only 2% with threshold 0.8. So there is no right or wrong answer. You really have to account for, is it an exploratory study? Are you trying to capture as many instances of toxic interactions? Then perhaps setting threshold 0.7 is appropriate, while realizing that there may be some false positive results. Alternatively, if you have space in the paper, perhaps reporting on multiple thresholds also makes sense. But on the other hand, if you really want to be more sure to reduce false positive results, setting a harsh, very high threshold of 0.9 will only find more kind of explicit forms of toxicity, but at least you will be sure that there will be or should be fewer false positive results. So I think those decisions needs to be discussed in the context of your domain, data set, and so on. And again, each threshold will determine where you're at on this curve. Remember, we talked about this curve. So depending on the threshold, you will be either capturing a lot of false positives, but also capturing, true positives, but also capturing false positives like here, or maybe you will be capturing fewer false positives if you set threshold, let's say 0.9, but then all of them will be true positives, so most of them. Now the question about correlation. So I remember a couple of you asked me, what's the difference between insults and toxicity? What's the overlap? We also wondered about that these questions as well. And so we ran for the Meta Canada data set. We did just simple correlation. You can do it in any software, SPSS, R, Excel. And so you just compare the toxicity scores. And so you can find that severe toxicity and toxicity, not surprisingly, highly correlated. So there are certainly fewer messages that would be classified under severe toxicity, but among them, of course, all of them will be toxic. So that's why the correlation is quite high. With insult, you see very similar pattern, and correlation, even you can see slightly higher than severe toxicity with toxicity. Same with profanity. So if you consider like what measures should you use for your research, is it toxicity, is it severe insults, or profanity? All 4 measures based on our data sets are highly correlated, correlation 0.9 and above. So in a way, it's really up to your research question. Are you only interested in examining direct attacks, insults? Then the insulting category makes sense for you. Or are you trying to cast a wider net? So then perhaps profanity or toxicity scores will be more appropriate. And again, keep in mind that the evaluations that I showed you for unintended biases right now, from what I can tell, only available for the only toxicity score, the more generic one. So from the publication perspective, it certainly will be easier to explain or provide evaluation for that measure than some other ones. Identity attack and threats are more different measures, are most different, I would say, than the 4 other ones. So if you're in research design, you're looking at toxicity and then looking additionally at identity attack and threat, that makes sense because 3 measures are quite different conceptually, as well as clearly shows assign different scores to different measures. Now, what else you can do? You can do a lot of things with scores, but first you will need to export them. So in Communalytic, there are limited features to explore these scores. We do integrate these toxicity scores as part of the network analysis and network visualizations. Some of them we will be covering in July. So I think that's an exciting new direction. You know, we merge in this toxicity analysis with network analysis. It's a very new, interesting opportunity to look at the data sets. We'll examine that in July. But otherwise, I do suggest you to export your data set as you would normally do from Communalytic. And you'll see this CSV file, which can open Excel or Google Spreadsheets. And if you export the same data set after you ran toxicity analysis in Communalytic, you will find additional columns in your data set. So the columns will include scores for each message. And this is where you can slice and dice it. You can run your correlations or other type of analysis you want for any measures in relation to any data sets.